Normal Distribution, Chapter 4. In this lecture, we are going to understand the normal distribution, the different characteristics of the normal distribution, and how to use the z-score formula to solve problems. Also, we are going to understand the t-distribution, characteristics, and when to use it, and other tests that we can use for normality. Characteristics of the normal distribution. One type of population that is very common is called the normal curve or Gaussian distribution. The normal curve is a symmetrical, unimodal, and bell-shaped distribution with the mean, the median, and the mode having the same value. So it looks like this figure. To be able to build different type of distribution, you just need to have a set of data and develop a frequency histogram. And what is good about the frequency histogram is help us to understand the type of distribution that a data set may have. We usually want those type of distributions to be normal, and it's because it's easier to work with the data and the formulas, and because the normal distribution also have a table that we can use. So whenever you graphic your data in a frequency histogram and you kind of get this type of shape, you can say that the distribution that these data are following is a normal distribution type. Now, when the mean, the mode, and the median are located in the same place, is what we call the standard normal distribution. And this value is equal to 0. So when the standard normal distribution is a normal distribution, means that the mean, the mode, and the median are equal to 0. And the standard deviation, which is a measure of dispersion, is equal to 1. When we have this type of distribution, this can be transformed to a standard normal distribution by the formula of the z-score. The z-score is equal to the observed value minus the mean or the average divided by the standard deviation. These z-score help us to work or massage our normal distribution data better, because from here we can use the tables, and the table can help us to find out what is the probability under that area, under the curve, and it's easier to work problems when the data is normally distributed. So, how do we understand the relationship between the mean, the standard deviation? Because the mean is a measure of central tendency, and the standard deviation is a measure of dispersion. As you can see in this figure, the mean for both curves are the same, which is equal to 52. That means that they are located at the average of those both distribution is 52. However, the standard deviation are different. One is 24 and the other one is 12. So what the standard deviation is telling us is how our data are spread out in relationship to that average of 52. So when you have a higher standard deviation, it means that you got more variation in that data set. And you can see that the shape of the curve is flatter. The other curve with the standard deviation equal to 12, you can see that has a better peak. This is another example. You have the same standard, the same mean, the same average of 52, and you have different standard deviations. One is 6 and the other one is 12. So the one with the 6, you're going to see a higher peak because the data is not spread out as much as the one with the standard deviation equal to 12. If the distribution is normal, the mean is the best measure of central tendency that you can use. Another characteristic of the normal distribution is given by the standard deviation, because the standard deviation once again gives you what is the spread out of the data in terms of that average. A normal distribution has 3 standard deviations to both sides. So you got 3 standard deviations to the right side and then 3 standard deviations to the left side. One standard deviation will include 68% of the total data. And you can see that. 2 standard deviations will include 95% of the data. 3 standard deviation will include 99.7% of the data. So we will always like to work with 3 standard deviations. That means 6 standard deviations in total, 3 from one side and 3 from the other side. So how do we construct a normal curve? The first step is to draw the normal curve. Once you have the data, you go and do a frequency histogram and you develop the curve. Once you do that, you're going to locate the given values. If they give you the mean, remember the mean is always in the center. And then if they give you a observed value, you locate that observed value based on that mean value. Means that if the mean is equal to 12 and you have an observed value equal to 10, the 10 will be to the left side of that mean. Once you do that, you calculate the z-value, the z-score. Remember, the z-score is equal to the observed value minus the mean divided by the standard deviation. Once you do that, you're gonna obtain a value. This value is the one that you're gonna use to read the table that is located in the back of your book on page 513. This table will help us to find out what is the probability of that specific observed value to be smaller or greater. It's depending on the problem statement that you're looking for. But that's how we read the table. We have to read the table with the z-value. For example, if we have a mean weight of a product equal to 0.302 kilograms and you have a standard deviation of 0.025 kilograms, what will be the percentage of the product below 0.280? So the first thing is that you need to understand the values given, and these are the mean, the standard deviation, and observed value. Once you do that, now you have to draw the normal curve. You draw a normal curve and you have to locate the different values. You locate first the mean, which is 0.302. Then you see what is your observed value, and because the observed value is less than the mean value. So you locate it to the left side. And then you understand the problem statement. And the problem is asking you what is that probability, the percentage of the products being below that observed value. So we're looking for everything that is to the left of that observed value. Once you have this, the next step will be to calculate the z-score. And the z-score is equal to the observed value, which is 0.280, minus the mean, which is 0.302, divided by the standard deviation, which is also given in the problem. Then you're going to obtain a value of minus 0.88. With this value, you have to go to the table, page 513. Oh, actually is, for this one is page, let's see, 512. How do you read the table? You have to go, the left column, the x sub I minus mu divided by the standard deviation is the z value, okay? So that's your very left column. With that column is how you're going to enter and read the table. So you look for minus 0.8, and then you start reading to your right until you touch that 0.8, which is the very top vertical row. So with the minus 0.88, reading that, touching that 0.08 column, you're going to get a value of 0.1894. Okay? Which is directly the percentage that you're looking for. So the percentage of the product being smaller than the observed value is 18.94. The table in your book gives you the area of the distribution, the probability, that is from minus infinity to that observed value. Okay? If you want to find out what is the probability between two observed values, you will have to find two z-scores. One for the observed value 1, the other one for the observed value 2, and you will subtract the difference. And the difference will be what you're looking for. If you're looking for the percentage of being higher than the observed value, which is to the right side, you'll find, because the table gives you the left side, and then you will subtract that value from 1, because everything under the normal distribution, because this is a probability, and the rules of probability says that it will be a number between 0 and 1, so the probability under the normal distribution is all of this area is equal to 1. That's why it's here that you obtain the answer from the table, like in this case, because it's asking you for the left side of the observed value, or you subtract the table value from 1. This is in the case that you're looking for the right side of your observed value, or you subtract a smaller table value from larger. That is in the case that you have two observed values and you want to find the probability of that to be between those two values. So that's how you use the normal distribution and the z-score. Now, when you have a normal distribution but your sample size is small, is when you're going to use the t-distribution. And the t-distribution is for sample size that are smaller than 30, and it's used the same way as the normal distribution. And you also have a table. I believe you have a table in your book. Let me look the page. No, you don't have a table on your page. You can find tables online. And you will find out that t-value from a formula. And with that t-value, you are going to read the table. You also need the df value, which is calculated using n minus 1. So if your total sample size is 20, the df will be n minus 1, which is 19. With that value of 19 and the value of t, you will read what will be the probability. So how do we calculate t? It's equal to the observed value minus the mean divided by the standard deviation divided by the square root of n. That's how you calculate the t distribution. So remember, the normal distribution is used for larger sample size, and when you have a sample size that is smaller than 30 and is following a normal distribution is when you're going to use the t distribution. Now, because I mentioned before that it's always good to work with a normal distributed data set, you always going to you would like to find out what are if your data set is normally distributed. So how do you do that? You can graph your data in a histogram, and if you see that you have a bell shape, a symmetrical, and you have large sample size, you can from there you can determine that your data is normally distributed or not. You also can use the Q-nets and cortices, and these are other type of measurements that we use to describe data. The Q-net is A sub 3 and the cortices is A sub 4. And if the A sub 3 is equal to 0, that means that it is as well is symmetrical. Okay. If the value is positive, or negative, it just means that it's either skewed to the left or skewed to the right, but it could still be normal distributed. If your cortice, which is A sub 4, is equal to 3, and this means that it's normally distributed. Because remember, the cortice gives you the peak of the data. And for these, usually they require a large sample size, so you can determine if it's normally distributed or not. Also, you can use probability plots. And the way that you do it is you order the data from the smallest to the largest. Then you rank the observation, starting from 1 for the lowest observation. And then you calculate the plotting position. Then you label the scale, you plot the points, and you try to attempt to fit by eyes a best line, a straight line. And if most of your data are on the line or very close to the line, you can determine if your data set is normally distributed. All of this type of graphical methods, you can do it by hands, you can do it using Excel, you can do it using Minitab. Another test for normality is the chi-square. And this is also is heavily used in statistics, because the idea is that, once again, you want your data to be normally distributed, because that's the easiest data, or the easier way to work with the data. And the chi-square can help to determine if that data is normally distributed. For the purpose of this class, we are going to be heavily use the normal distribution and the z-score value, but you need to have knowledge that there are other type of distribution, such as the t-distribution when you have a small set of data, and there are different methods to determine if your data are normal distributed or not.